In this last video for our organic and non-organic reaction types, we have two inorganic reactions. So these are reactions that don't involve mainly carbon and hydrogen. There might be carbon in them, but they're not what we would call organic reactions. So we have single replacement and double replacement. They sound very similar. And the reason they sound similar is because they look very similar. But it turns out, we will learn later on in the year, they're nothing alike, meaning what drives these two reactions to happen is totally different principles within chemistry. So we're going to learn about them at different times of the year. Single replacement we'll learn first, and double replacement we will learn, double replacement we'll learn first, and single replacement will be like the last thing we learn for the entire year, because they're actually pretty complicated as far as what causes them to happen. But for now, we'll just learn to identify them. So here's my examples. So I have element A, element B, element C. So these are different elements. And the way you identify a single replacement reaction is an element and part of a compound trade places. So I like to call it element compound swap. So I take the element A in this case because it's alone, and the compound B because it's part of a compound. It's with C, that's what makes it part of a compound, and they trade. Does it have to be A and B that trade? No, A and C can trade as well. It doesn't really matter. As long as you have an element trading places with a compound, you end up getting a new element and a new compound. So the example would be B alone is a new element because here it was part of a compound, and now AC is a new compound because it's different from BC. So here, take a look. We have Zn trading places with the copper. So you end up with copper alone, now it's an element, it was in a compound, and the zinc was an element, it's now in a compound. So element, compound, swap. Bromine and iodine trade places. Now you don't have to worry about the fact that it's Br2 here, and then it's only Br here. That has to do with, when you form ionic compounds, they come together in different ratios, and then we use balancing, which you haven't learned yet, to take care of the fact that they're unequal. Again, we're going to learn it very soon, so it shouldn't be too big of a deal. But all you need to say is, all right, this is an element. This is a compound. Part of this element is trading places with part of this compound to make a new compound, Na with Br, and a new element, I alone. Done. In this one, K trades places with one of the H's. So that still counts because now K was an element, it's now in a compound as KOH, and H was in a compound, and now we have H outside the compound. Now granted, H is still in the compound here, but we also have elemental H, which is what's important there. So that's how you figure out if something's single replacement. At this point, you will not have to figure out the products. You're just going to have to identify the reaction for now. And then double replacement, I like to call this one compound swap. In other words, I take two compounds and they swap their positive ions. Or you could word it and say, well, they're going to swap their negative ions. It doesn't matter how you say it. You end up with the same result. Meaning Na is a metal. It's going to be the positive thing in the reaction. If you didn't know that, you should know how to assign oxidation numbers. If you don't know that, go back and watch my video. But you're going to basically trade places with the H, and the Na comes out. And so what do you get? The H is now with Cn, right? Because this is the polyatomic. And the Na is now with SO4 because SO4, again, is a polyatomic. You don't need the parentheses around it. I'm just writing it in so you can see the polyatomics to make them a little bit easier. But the sodium and the H swap. For this next one, this is a polyatomic. NO3, obviously, S is an element, but sodium is going to trade places with Cd. And so sodium is a metal. It's now going to be with NO3, and NO3 was the metal here. It's now going to be with S. So you may not get the same amount of each, but you do get new compounds being formed, and that's what's important. And then the last one, calcium is going to trade places with hydrogen in this case to make H with OH, otherwise known as H2O. That's what it would look like, but we're never going to write it that way. That's why it changes form. And then calcium is now going to be with chlorine. So these are double replacement reactions. Basically, the one element in the compound trades with the other element of similar charge. In other words, you could say the positive ions, which are typically the metals, they can swap. Or you could say that the negative ions swap. I like to do the positives because they're always written first, so it just makes things easier. But you could view it as the metal swapping. It wouldn't necessarily be wrong. It would just be a little bit more work. So that is all the reaction types, both organic and inorganic, that we have to know about for chemistry this entire year.